Hi and welcome to paper one of the 2018 Junior Cert Higher Level. As usual, if you want to copy the notes I'm working off, just send me an email at shanetroy@gmail.com, and that email address is in the description below. So question one here is a sequence and series question, and just got stuck in. So part A here says only one linear pattern begins with 1, 7. Okay. Fill in the three boxes below so that the numbers form this linear pattern. Now, a linear pattern, okay, will be going up in the same amount each time. Okay, so its first difference, we also refer to it, is the same. So, what's the difference between 1 and 7? Okay, we'll just do a calculation, and I would show the calculation. 7 take 1 equals 6. Now, you're most certainly up here on the 3 marks right now, just for that. So, well, if that pattern holds, and it is linear, it will hold. 7 and 6 give you 13. 13 and 6 would be what, 19? And 19 and 6 would be 25. Okay, so each time there's a difference of 6. I'll show you on the next page, it's the answer done in. So it's the same one. So in a linear pattern, the change in the numbers is constant. Therefore, the slope is constant, which is a feature of linear equations or linear patterns. Okay, so that's part A. Now part B is a little bit trickier, okay, and I'm not 100% comfortable when it comes to quadratic patterns and sequences. But there's a few things you're kind of looking out for, a few tropes as such. Now this is worth a fair chunk of marks, 15C marks, okay, so, and it does come up an awful lot. So it's worth going back to your textbook and having a read of the section on sequences and series, the chapter text as such, and just trying to get familiarity with the background. Because again, with junior to higher level, as I've probably discussed in previous questions, they're often testing your deeper understanding, not just a calculation. Okay. Now, part B says many different quadratic patterns, so they're giving you a hint here, begin with 1, 7. Fill in the three boxes below so the numbers form a quadratic pattern. Now, we said with a linear pattern that the first difference was constant. Okay. In a quadratic pattern, it's the second difference. Okay, it's constant. Or at least, more correctly, the second difference is not 0. Okay. So we're trying to pick here, and I'm going to go to the answer because it's not complicated, but it's going to work through it. I've picked numbers, okay, that the second difference doesn't give 0. Okay. So I went up 1, 7, okay, 15 now, 15, 25, 37. Now the first difference there, okay, is not constant, so it's not linear. Okay, 7 minus 1 is 6. 15 minus 7 is 8. 25 minus 15 is 10. 27 minus 25 is 12. So the first difference is not constant. Now, if I get a second difference here, take the differences away. Okay, so the first difference is basically the slope. The second difference is, for lack of a better word, the slope of the slope. Okay, and 8 take away 6 is 2, 10 take away 8 is 2, 12 take away 10 is 2. So the second difference pattern in this case is the same, okay, but ultimately it's not 0. Okay, now that takes a bit of time to kind of pick it out. There's multiple answers here. It's not like 15 has to be the answer. As long as whatever you pick here, the second difference is not 0, it's gravy. Okay, so just a good understanding of that would help. Now, if they ask quadratic patterns, and I said they have numerous times over the last few years, if you don't really understand what you're doing, you're going to be flapping around and struggling. Okay, if you do have a fairly good handle on the difference between arithmetic sequences, geometric sequences, and quadratic patterns, linear patterns, this question can be fairly handy. Okay, and I think that's basically it for this question. Okay, so that's it, and see you on question 2.